Hi, welcome back to the online video lecture. Now we'll see about the next concept, new data services in GSM. Now if you consider the today's requirement of the computer, so nowadays the data services is providing the standard bandwidth of up to 9.6 kilobit per second. So which are available for the data transmission is not sufficient if you consider the today's requirement of the computers. Now when GSM was developed, not many peoples are expected the tremendous growth of the data communication, so which was compared to voice communication. So at that time 9.6 kilobit per second was a lot, or at least for the enough for the standard group 3 packs machines, right? So this speed is enough initially when the GSM was developed, but with the requirement of the today's for example web browsing, file downloads, or even intensive email exchange with attachment, so this is not enough, or not enough for the internet and multimedia applications. So to enhance the data transmission capability of the GSM, so two basic approaches are possible. So as the basic GSM is based on the connection oriented traffic channels. So for example 9.6 kilobit per second each, and several channels could be combined to increase the bandwidth. Now, so this system is called as a high speed circuit switch data, or in short we can call them as a HSCSD, right? So high speed circuit switch data network. And again the one more progressive steps in the of the GSM is the introduction of the packet oriented traffic in GSM. So that is shifting the from the connection or telephone thinking to the packet or internet thinking. So that is the GPRS. So the another service we'll see next. Now first we'll discuss about the HSCSD. So the further improvement of the GSM data transmission capability is the high speed circuit switch data, so which is available with some provider nowadays. Now in this system, higher data rates are achieved by bundling the several traffic channels. Bundling the several traffic channels. So if you consider the mobile station, right? So a mobile station requests one or more traffic channels from the GSM network. That is, so it allocates the TDMA slots within a TDMA frames, right? So this allocation can be asymmetrical, that is more slots can be allocated on the downlink than on the uplink. So downlink means the transmission, so we are transferring the data from base station to the mobile station, and uplink means from mobile station to the base station, right? So here the basically HSCSD only require the software upgrades in mobile station and the mobile station controller. Both have able to split a traffic stream into the several stream using the separate traffic channels for each, right? And to combine these stream again, right? So theoretically, if you consider this concept theoretically, the mobile station could use the all 8 slots within the TDMA frames to achieve the air interface user rate. So here it is shown AIUR, air interface user rate, right? So for example, so here example is shown by considering this table. So 57.6 kilobit per second. So if you consider the traffic channels of the frequency 14.4, so air interface user rate is 57.6 using how many slots? 4 slots. of 14.4 each for each slot. So this 14.4 frequency is used of air interface user rate is 57.6. Now one problem of this configuration is that the mobile station is required to send and receive at the same time. So standard GSM does not require this capability. So uplink and downlink slots are also shifted for 3 slots, right? So here the 57.6 kilobit per second. So this air interface user rate using the 4 slot in the uplink and downlink, so which is specified in the ETSI, right? So advantage of this high speed circuit switch data is the ready to use, constant quality and simple. And disadvantage of the HSCSD is the channels blocked for the voice communication. It still uses the connection oriented mechanism of the GSM, right? So another disadvantage of this high speed circuit switch data is while downloading a larger file, so may require all channels reserved. So typical web browsing would leave the channels idle most of the time, right? So allocating channel is reflected directly in the service cost, as once the channels have been reserved, other user cannot use them, right? So each channel is treated separately here. The probability of blocking or service degradation increases during the handover, right? So everyone knows, I hope everyone knows the handover concept, right? And here in this case the base station controller has to check the resources for the channels, not for the rest one, right? So this is about the high speed circuit switch data, right? And the next data services in the GSM, that is the GPRS, General Packet Radio Services. The next steps toward the more flexible and powerful data transmission. So avoid by using this GSM, so we avoided the problems of HSCSD by using the fully packet oriented, right? So few of the drawbacks. So while at the downloading time, so larger file may require the channel all channel reservations and so many drawbacks. So all these drawbacks is resolved by using this packet switching. So here in the GPRS we are using the packet switching. Now this GPRS provides the packet mode transfer for applications, right? So that executes the traffic patterns such as the frequent transmission of small volumes, that is the typical web request, or infrequent transmission of the small or medium volumes, right? Uh, that is typical web responses also according to the requirement specification, right? So compared to the existing data transfer system or existing data transfer services, the GPRS should use the existing network resources more efficiently for the packet mode application, and should provide the selection of the quality of service parameters for the service requesters, right? So here in the GPRS also allows for the broadcast, multicast and unicast service. The overall goal of the GPRS system is the provision of more efficient and cheaper packet transfer service for the typical internet application, right? So that usually rely on the packet transfer, right? So network providers typically supports this model by changing on volumes and not on the connection time as usual for the traditional GSM data services and the HSCSD, right? The main benefit of the users or main benefit for the user of the GPRS is always on, right? So this is the benefit to the users by using this GPRS service or by using this new data services, that is the GPRS. So it always on. So this is the characteristic, always on. No connection has to be set up on prior to the data transfer, or before data transfer no need to set up the connections for the data transfer. So GPRS is always on, right? So GPRS was tremendous success of the packet oriented internet system, right, or service. So by the new traffic model and application is concerned. So here this edge as CSD and GPRS so does not only represent the software updates to allow for bundling of the channels, it also represent the big steps. So this is the advantage, one steps toward the or big step toward the UMTS, universal mobile telecommunication system, as the main internal infrastructure is needed for the UMTS in its initial release. Is exactly what the GPRS use. And disadvantage is more investment needed, new hardware. So if you consider the GPRS, so here more infrastructure is required. So new hardware is also required. So more investment is needed. So more investment. This is the disadvantage of the GPRS, right? The main concept of the GPRS system is so can allow. So here we are using the some time slot. So by using the TDMA frame, right? So time slots are not allocated in fixed or is predetermined manner, but on demand. So dynamically time slot is allocated or that is shared with the active users, right? Up and down links are allocated separately. So in the GPRS, so allocation of the slot is based on the current load and operator preferences, and again the depending on the coding, and transfer data rate up to 170 kilobit per second is also possible, right? So GPRS services can be used in parallel to conventional services, right? Now sometimes this GPRS can also be used for other TDMA system also. Now in the beginning, now before going to the next part, so GPRS network elements. So these are the GPRS network element GSN. So GSN means GPRS support nodes. So gateway, GPRS support node, and service GPRS support node, um, serving sorry not service serving GPRS support node, right? So gateway GSN or gateway GPRS support node, interworking unit between the GPRS and packet data network. So that we will discuss in detail at the time of GPRS architecture. SGSN, serving GPRS support system, now supports the mobile station for localization, billing, and security purpose. GR, this is the GPRS register. So all user addresses is stored under the GPRS register. So these four elements we are going to, we are already, this four element is used in the GPRS network. Now in the beginning only the coding scheme. So coding scheme. So here CS1, CS2, CS3, CS4. So these four are the coding scheme, and these are the slots. And according to the slots, so here the data rate is given in kilobit per second. So one slot, and if you are using the CS1 coding scheme, so 9.05 kilobit per second data rate used for the 2 slot, 3 slot, 4, 5, 6, 7, 8 up to 8 slots. And here the coding scheme is also given. So in the beginning only CS1 and CS2 coding schemes are available. Now the system selects the coding scheme depending on the current error rates. And it should be noted that the real available data rate heavily depends on the current load of the cell, as the GPRS typically only uses the ideal time slots. Right? The transfer rate depends on the capability of the mobile station. Not all devices are able to send and receiver at the same time. So here the another table shows the classes, right? So here the device classes, the ability to use the time slot for sending and receiving the data, or maximum possible number of slots, maximum possible number of slots limits the transfer rate even more, right? So here if you consider the class 1, right, the receiving slots 1, sending slots 1, maximum number of slots are available for this GPRS class 1 GPRS is the 2. So for example, we'll consider the class 12 device, right? So may receive the data using 4 slots within the GSM time frame, or it may send the data using the 4 time slots. Now, however, the maximum number of 5 slots may be used altogether. Now, using all 8 slots for the data encoded using CS4. Now, here CS4 is used, right? So, maximum rate of the data is 171.2 kilobit per second. Now, today the typical mobile station is of class 10, right? So class 10 device using the CS2, using the CS2, so which results in receiving rate of 53.6 kilobit per second and sending rate of 26.8 kilobit per second, right? So this is about the GPRS device classes and GPRS user data rates in kilobit per second, right? So if you talk about the GPRS, so in phase 1, the GPRS offers the point-to-point packet data transfer services, right? So point-to-point means, in short, we can call them as a PTP version, right? So PTP offers for initially connection-oriented network service, so which includes the ability of the GPRS to maintain the virtual circuits upon change of the cell within the GPS network or within the GSM network only, right? And the another version of the point-to-point packet transfer service is the connectionless network service. In short, we are calling them as a PTP CLNS, right? Which supports the application that are based on the internet protocol IP, right? And another version or another in the phase 2, the GPRS offers the multicasting, so we call them as a point to multicast service, that is PTM, right? So users of the GPRS can specify quality of service provided by using this. Now this determines the services by considering the high, normal and low reliability classes and delay classes of the transmission and user data throughputs. GPRS should allocate the radio resources to fulfill these user specification. So to fulfill this reliability related things and delay related class, so we need to specify the resources, radio resources accordingly, right? Now the next part will discuss about the GPRS architecture. Now here the GPRS architecture introduces the two new network elements. So two new network element already we discussed in the first slide. So which are called as a GPRS support node, GSN, GPRS support node, and are in fact, so we are calling them as a router. So all GPRS support nodes are integrated into the standard GSM architectures, and many new interfaces have been defined. So first, the gateway GPRS support node. So GGSN, gateway GPRS support node, is the interworking unit between the GPRS network and the external PDN or packet data network. Now this node contains the routing information for the GPRS users, performs address convergence, and tunnels the data to a user via encapsulation. And the gateway GPRS support node is connected to the external network via GI interface. So this GI interface is used for the connection and transport packet to the SGSN via an IP based GPRS backbone network, that is GN, IP based GPRS backbone network through GN interface. And the other new element here is serving GPRS support system, which supports the mobile station via the GB interface. Via GB interface. SGSN, for example, requests the user address from the GPRS register. Now, if you want to request for the address purpose, so SGSN need to request for the GPRS register, keep track of the individual mobile station, track of the mobile station means, so you need to update the location of each and every mobile station, and also this GR is responsible for collecting the bill information, for example counting bytes, and perform the several security functions such as access controls. All these things are done by using only GPRS registers. So SGSN is connected to the base station controller or BSS via a frame delay and is basically on the same hierarchy level as in the mobile station controller. In the same hierarchy level by considering this mobile station controller. Now GR, which is typically part of the home location register, stores all GPRS relevant data. So GGSN and SGSN can be compared with home and foreign agent respectively in a mobile IP network. So packet data is transferred from this PDN via GGSN and SGSN directly to the BSS and finally to the mobile station MS. And the mobile station controller, which is responsible for data transport in the traditional circuit switch GSM, is only used for signaling in GPRS scenario. Now before sending any data over the GPRS networks and or throughout the GPRS network, mobile station must attach to it. So before transferring any of the data or sending any of the data over the GPRS network, you must or you need to attach the mobile station to the network. So this is about the GPRS architecture and interface.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.